Our planet is facing a challenge of unprecedented scale climate change. The signs are everywhere, from melting ice caps to extreme weather events that are becoming more frequent and severe. The burning of fossil fuels is releasing harmful greenhouse gases into the atmosphere, contributing significantly to global warming. This is warming the planet at an alarming rate, causing polar ice to melt and leading to droughts in various regions. Scientists warn of dire consequences if we fail to act. The time to make a change is now, before it's too late. We need a solution and we need it now. Enter clean hydrogen, a promising alternative to fossil fuels. This versatile energy carrier holds immense potential. It can be stored and transported easily, making it a viable option for various applications. It can be produced from renewable sources, leaving a minimal carbon footprint. Wind, solar and hydroelectric power can all be harnessed to generate hydrogen. Hydrogen can power our homes, fuel our vehicles, and even propel industries forward. Its applications are vast and varied. It offers a beacon of hope in our fight against climate change. A future powered by hydrogen is a future where clean energy is the norm. Imagine a world where the air is clean and energy is abundant. This is not just a dream, but a tangible possibility. This is the promise of a hydrogen-powered future. A future where cities are green and transportation is eco-friendly. But how do we make this vision a reality? The answer lies in innovation and investment in hydrogen technology. The answer might lie in the vast potential of our oceans. Harnessing marine energy could be the key to unlocking a sustainable hydrogen economy. Look out at sea and you'll see a powerful force at work, the wind. This invisible force has been shaping our world for millennia. This natural resource has been harnessed for centuries to power ships and windmills, driving exploration and agriculture. Now it's poised to play a pivotal role in the clean energy revolution, transforming how we generate electricity. Offshore wind energy is rapidly gaining momentum, with new projects being launched globally. Technological advancements have made offshore wind turbines more efficient and affordable than ever before, pushing the boundaries of what's possible. They tower over the ocean, capturing the kinetic energy of the wind and converting it into electricity, providing a steady and reliable power source. Unlike fossil fuels, wind energy is renewable and sustainable, offering a cleaner alternative to traditional energy sources. It's a gift that keeps on giving, with each gust of wind contributing to a greener planet. Offshore wind farms are popping up around the world, from Europe to Asia and beyond. They are a testament to our commitment to a cleaner future, showcasing our dedication to sustainable development. But what if we could take this clean energy source and use it to create something even more versatile? The possibilities are endless. This is where hydrogen comes in, offering a new frontier in renewable energy. Hydrogen is the most abundant element in the universe, making up roughly 75% of its elemental mass. It's a colorless, odorless gas that holds immense energy potential, often referred to as the fuel of the future. When hydrogen is burned, it releases energy and water vapor. No harmful emissions whatsoever, making it incredibly clean. This makes it an ideal candidate for a clean energy future, potentially revolutionizing how we power our lives. But hydrogen doesn't exist in its pure form naturally. It's always bonded with other elements. It needs to be extracted from other sources, such as water or natural gas, through various processes. This is where the concept of green hydrogen comes into play, offering a sustainable solution. Green hydrogen is produced using renewable energy sources like offshore wind to split water molecules into hydrogen and oxygen, a process known as electrolysis. This process, called electrolysis, is clean, sustainable, and holds the key to unlocking a hydrogen-powered future free from fossil fuels. By harnessing the power of offshore wind, we can produce vast amounts of green hydrogen, ready to fuel our world, reducing our carbon footprint significantly. Imagine a symbiotic relationship between two clean energy giants, offshore wind and green hydrogen. This is the vision of a sustainable energy system that is both abundant and environmentally friendly. Offshore wind farms with their massive turbines generate vast amounts of clean electricity. However, storing and transporting this energy can be a challenge. This is where hydrogen comes in. By using offshore wind power to produce green hydrogen, we can store this energy in a highly portable and versatile form. This green hydrogen can then be transported to shore, where it can be used in a variety of applications. It can power fuel cells in vehicles, heat our homes, and even be used as a feedstock in industrial processes. The possibilities are as vast as the ocean itself.
Section 5. Onshore versus offshore. Weighing the production battlefield. When it comes to producing green hydrogen, we have two main options, onshore and offshore. Both approaches have their own set of advantages and disadvantages. Onshore hydrogen production involves building electrolysis facilities on land, typically near renewable energy sources like wind or solar farms. This approach benefits from existing infrastructure and a readily available workforce. However, land availability and proximity to renewable energy sources can be limiting factors. Offshore hydrogen production, on the other hand, takes advantage of the vast space and abundant wind resources available at sea. By integrating electrolysis facilities directly into offshore wind farms, we can eliminate the need for costly transmission infrastructure. However, the harsh marine environment poses significant technical and logistical challenges.
Section 6. The numbers game cost analysis of green hydrogen. To determine the feasibility of green hydrogen production, we need to crunch the numbers. This involves analyzing various cost factors, including capital costs, operating costs, and the cost of electricity. The cost of electricity is a major driver of green hydrogen production costs. Offshore wind power, with its high capacity factors and declining costs, is emerging as a cost-competitive source of renewable energy for electrolysis. By integrating electrolysis facilities directly into offshore wind farms, we can further reduce costs by minimizing transmission losses and taking advantage of shared infrastructure. This co-location approach can significantly improve the economics of green hydrogen production. Section 7. Financial viability. Can green hydrogen turn green profits? Investors and policymakers alike are keen to understand the financial viability of green hydrogen projects. This involves assessing key financial metrics such as net present value, internal rate of return, and payback period. The financial performance of green hydrogen projects is highly sensitive to factors such as the cost of electricity, capital costs, and the market price of hydrogen. Government policies, such as carbon pricing and renewable energy incentives, can play a crucial role in improving the economics of green hydrogen. As the cost of renewable energy continues to decline and the technology matures, green hydrogen is becoming increasingly cost competitive with conventional hydrogen production methods. This is attracting significant investment from both the public and private sectors.
Section 8. Challenges and opportunities. Navigating the hydrogen seas. The path to a hydrogen-powered future is not without its challenges. We need to overcome technical hurdles, ensure the safety of hydrogen infrastructure, and address public perception concerns. One of the main technical challenges is developing efficient and durable electrolyzers that can operate reliably in harsh marine environments.
We also need to establish robust hydrogen storage and transportation infrastructure to connect production sites with end users. Public acceptance of hydrogen as a safe and viable energy carrier is crucial for its widespread adoption. Education and outreach programs can help address concerns and build public trust in this emerging technology.
Section 9. The future is green, the promise of scalable hydrogen. Despite the challenges, the future of green hydrogen is bright. As the technology matures and scales up, we can expect to see significant cost reductions and performance improvements. Governments around the world are recognizing the potential of green hydrogen to decarbonize their economies. They are investing heavily in research and development, providing financial incentives, and establishing policy frameworks to support the growth of the hydrogen industry. The transition to a hydrogen-powered society will require a collaborative effort from governments, industry, and research institutions. By working together, we can unlock the full potential of green hydrogen and create a cleaner, more sustainable future for all.
Section 10. Conclusion. Charting a course toward a sustainable future. The integration of offshore wind and green hydrogen production holds immense promise for a sustainable future. By harnessing the power of the wind and the versatility of hydrogen, we can decarbonize our energy systems, reduce our reliance on fossil fuels, and mitigate the impacts of climate change. While challenges remain, the rapid advancements in technology, coupled with supportive government policies and growing private sector investment, are paving the way for a hydrogen-powered future. As we chart a course toward a more sustainable future, green hydrogen will undoubtedly play a pivotal role in powering our world.